Okay, now I want to talk a little bit about dimensional analysis, and I'll write this here really quick, dimensional analysis. And this is one of the ways that units can actually be used for our own benefit to make sure that we solve the problem right. So units can be our friend, and that's what I'm about to show you, okay? So whenever you solve a problem, by the way, you should be on the dimensional analysis slide. Whenever you solve a problem in physics, the units of the variables must always cancel out to reveal the units of the answer that you're getting, okay? And so in general, when we're doing a dimensional analysis, whenever we're talking about a length, we have this little L here. Whenever we're talking about time, we have this capital T. And when we're talking about mass, we have this mass, right? So we're not worried about what specific units we're using, but we're just worried about making sure that we know that all length units are measured, are labeled L, all time units are measured T, and all mass units are measured with a big M, okay? So let's do an example. Go ahead and advance to the next slide. And it says, you know, we have this formula, x equals 1/2 VT squared. How can we prove that that formula is wrong, okay? Well, we can use dimensional analysis to show how messed up this equation actually is. So x is a distance, right? That's a length. So I'm going to put L in for x, right? And then I have 1/2. Velocity is a length over time. Okay, it's speed. Speed is distance divided by time. So that's length divided by time. So that's L divided by a T, right? And then we have T squared over here, which is a time squared. Okay, one of these times is going to cancel out with one of those times, right? And so I'm left with the units. Whenever we're doing dimensional analysis, we don't care about the constants, right? Because there's no units there. So we cross this guy out, right? And that makes us left with 1L and 1T. So that's going to be L equals L times T. Can that be true? Absolutely not, right? A length cannot equal a length times a time. So we know that we've chosen the wrong equation, okay? And this is something you can do many times over when you're solving your own problems. If you're not sure what an equation is, you can always use dimensional analysis to tell you if you got the wrong equation and even how to possibly change it to make the right equation so that the units actually work out, okay? So if you guys could go ahead and advance a couple slides to the misconception question, we will look at this, or at least do one more example before moving on from dimensional analysis. Okay, so in this example, it says consider the equation x equals 3z v divided by time. The dimensions of the variables v, x, and t are length over time, length, and time respectively. What must be the dimensions of the variable z such that both sides of the equation have the same dimensions? Okay, let's just use the dimensional analysis that we did before. We have x equals 3z v over t, right? Again, we know x is a length, so we're going to put in L for this guy right here. 3 we don't care about, so we can just leave him out. Z is what we're trying to find the units of. We know that v is length divided by time, right? And we know that we have time here on the bottom, okay? And so here's what we know. We know that this L here will cancel with this L here, right? And we know that this is L over T. This T is technically here on the bottom, right? Which means that Z is really just time squared, right? So that will be our units, which means that in terms of this misconception question, our answer should be D. Z should have the units of t squared in order to make this relationship hold, okay? Again, you'll have many opportunities to practice this, and if you have any questions, feel free to reach out in office hours.